Now we are going to discuss question number 6.15, and in this question it is given to you an air core solenoid with length 30 centimeter. So length of this air core solenoid, this is given L, this is equal to 30 centimeter. Find area of cross section. Area of cross section, this is 25 centimeter square. 25 centimeter square. Clear? So this is equal to 25 into 10 to the power minus 4 meter square. Clear? And it is also given number of tons. So number of tons, this is equal to 500. Clear? It is carrying a current of 2.5 ampere. So I equal to 2.5 ampere. Clear? Now it is also given the current is suddenly switch off. Okay, it means initial current we have, this is 2.5 ampere, and finally this is 0. Fine. Clear? And in the time interval 10 to the power minus 3 second. So I can say this is 10 to the power minus 3 second. Okay. Now how much is the average back EMF induced across the ends of the open switch in the circuit? Clear? So how much is the back EMF? So actually we know, can we find here initial magnetic field that is produced in a solenoid? Yes, we know formula. This is given by mu naught and I. Clear? Here we will write I initial, but important part is here what is small n. Small n is number of turns per unit length. Clear? So we can say this is mu naught capital N I divided by L. Now we can put here values 4 pi into 10 to the power minus 7. Number of turns we have 500. Initial current is given 5 by 2. Clear? And it is divided by length we can say 30 centimeter. So 30 into 10 to the power minus 2. Clear? I can say this one and this one cancelled out. From here we can say this is 2 pi. Clear? So we can see 5 multiplied 2 pi. We can say 10 pi and this one, that is 100 pi, and we can say 500 pi. So 500 pi into 10 to the power minus 5. Clear? And divided by 3. We can write like this. Yes or no? So from here we can say this is equal to 5 pi into 10 to the power minus 3 divided by 3. Clear? So pi equal to what? This is near about 3.14. So we can see initial, I can say initial magnetic field, this is given by 5 into 10 to the power minus 3 Tesla. This is near about value. Clear? What about B final? B final is equal to 0 because current that is flowing, this is 0. Now definitely whenever magnetic field is changing, it means magnetic flux will change. When magnetic flux change, it means I can say induced EMF will be developed, and this is given by delta phi by delta t. Clear? So what about phi initial? Clear? Actually we can see, we can write like this area, this is delta B by delta t. Clear? Now we can put here all values and we can get our answer. Clear? So now from here we can see, we can write here E, because our objective here in this question is to find average or back induced EMF. So we can write like this. Yes. So from here we can see induced EMF. Induced EMF equal to what? Area. Area is given 25 into 10 to the power minus 4 multiply we can say delta B by delta T. Clear? Delta B. Delta B means we can say what is change in magnetic field. So directly you can say you are finding here change of 5 into 10 to the power minus 3 minus 0 and divided by delta T. Delta T means we can say 10 to the power minus 3. This one and this one cancelled out. Clear? And we are getting near about value. This is 125 into 10 to the power minus 4 volt. Clear? Or you can also write like this. This is 12.5 into 10 to the power minus 3 volt, or near about 12.5 millivolt. Clear to everyone? So student, generally we will commit a mistake in this question here. Actually in this magnetic field we have already included number of turns, but here because we are talking about flux, and flux is also associated with n number of turns. Clear? So here you have to also multiply it with n also. Clear? So here we will multiply it with n also. Clear? So now we can say number of turns we have, that is 500. So we can multiply it with 500 also. Clear? So from here you can find here value 500. So at the time we can say this is 125 into, I can say that is 10 to the power minus 4 into 500. Clear? So from here we can say this is 625 into 10 to the power minus 2, and I can say that is volt. Clear? So this is all about this question. Clear?